Welcome to the project, everyone. We have a fun one today. Pinewood Derby. Background to where this project came from, my local youth group. I've asked about Pinewood Derby because I've done Pinewood Derby when I was a kid. And they kept saying, oh yeah, we've got tracks and stuff, but we don't have, well, someone's made a timing system, but I don't think it works and that kind of a thing. And me being who I am, I was like, oh, that sounds right up my alley. Like, I could get a timing system working, and then the the new generation can do Pinewood Derby, which is just honestly a fun project or a fun experience. So let me take you through my history of Pinewood Derby's cars. All of mine, my dad helped me build. This is my first one. And I did it after the Panos GTR 1. If you look up that car, it's quite the weird car. And this one, yeah, it kind of resembles it. It's pretty fun. But it's in the shop for repairs right now. I believe this is my second one, which is just, it's the GTR 2, and we like made the front like made a wedge front rather than like rolling it off, as you can see there. For my third one, I don't know why we just like clear coated it and I put in a bunch of hieroglyphs, but I did. So no idea, but they're all basically the same car. I love the look of that car. Which is kind of funny. So we need a timing system, and I've gathered what they had. I have the track, like the finish line section here, and then I have the finish line hoop right here. And essentially going into this, since we might be moving at some point, so I don't want to make a system that like only I can use. I want to do a system that, you know, anyone can just plug in and it'll work. I got all of the hardware that they have already, which is great because a lot of the stuff has already been done for me. And some of the stuff that I didn't really feel like building now has been built. So I can just concentrate on some of the more fun stuff. So this right here is the finish line, so the cars will come underneath it. And the way that it works is that there's little infrared LEDs right here underneath. As you can see, there's just little LEDs down between two copper strips in there. And this whole section is done pretty well. The way that this system works, there's a few different ways that you can like do timing on all of this, and I didn't know if I wanted to go the optical route. I almost thought of maybe trying to do something where the light shines up and as the car passes over it'll bounce down into the receiver. But essentially how it works is that light comes down and then you have a receiver right here. And as the car blocks the receiver, the amount of infrared light coming into it drastically changes. And we'll show all of this, but that's the basis of it. You've got a receiver, an emitter, and then something to actually like time it and see who comes across the line first. Thankfully, I just got this all set up for a little bit of a better filming situation. So I've got my power supply, my scope out here, so I can show you guys things a lot better. First, I think what's best is to show you how this works right here. And this is the current solution that they had. Everything's off the shelf, some other company made it, and essentially you plug all the sensors in and even like the start switch, so that way you can like see how long it takes to get from start to the finish. This stick right here, you have to plug into a computer. And then the computer is the one that actually has any sort of interface as far as who won, who did this or that. And so I really don't like this system because it requires someone with a computer, with software that's able to run it, and with this plugged in, all to get the timing to work. I'll show you how this works, but my idea in the beginning was to do like little LEDs, so each lane would have 4 LEDs on top, and then you could tell who went first, second, third, or even 3. First, second, third, and then fourth just wouldn't have any lit up. But after looking around, there's actually a lot better ideas. So I'll show you that in a minute, but first I will get this set up and then I can show you how this works. I guess first, let me show you this. So this board, it's basically just a processor and some flip-flops or some gates, so that way they can latch when it happens. And then I've just soldered on some 30 gauge wire right there, so that way I can see it on the scope. I'll see if I can get this set up at all, and then we can show it actually working. Okay, so here is the setup right now. So we do have just USB power into that board that's off the shelf. We have our sensor in here. That's its own system here. And then on the other side, we have my power supply here. And thankfully, we still had like the wall wart to power this, this hoop, whatever it's called, the finish line hoop. So I do know it's 3 volts right here. And so I have the power supply at 3 volts. And so now over here on the scope, we can see what the output from the sensor is. And there's just like a pull up on this side. So you can see right now with no input, with no infrared coming in, it's high. So what'll happen is I turn this on, so the infrared is on. And you can see it's basically 0 volts in there. And then as the car passes over, you see that? And that's basically how this whole system works. So we just need a processor on this line here to see when, whoop, a car actually passes over the finish line. And it could even be like way up here, though not as much. So there's the system working. And so what they have is they have 4 sensors for each. Ours is 4 wide, so we'll have 4 lanes, and each lane will have their own little input in here. Okay, so that is how the current system works, as you can see. So let me show you what I have in mind. So yeah, we're going to use an Arduino to power everything. And what I'm thinking to do is convert this to like 12 volts and then just use like a 12 volt barrel jack. And then have maybe the Arduino mounted up here. And I told you about my LED lights on top, but here's something better. So I've got my breadboard. Pull off these little guys. Rather than doing LEDs on top, I have seen other people do this, and it seems pretty standard, but 7-segment displays. You know, you probably have seen these. Technically 8 segments, but yeah, 7-segment display. We've got there on there. So if we do 7-segment displays on top for each lane, then you just have a big old number up here to show you who got first, second, third. These take 8 LEDs, and if I just did LEDs on the top here, then that would be 4 LEDs. So you know, doing 4 lanes with 4 LEDs each, we would run out of pins on here. So, pretty standard. What I was going to move to is shift registers. And I can show you guys how shift registers work. But we're going to use shift registers. That way, you only use at most like 2 pins, but I might use a bit more. And we can drive all of these. But here's the thing. This is really tiny. So, after doing a bit of digging, I found these honkers. Look at the difference. This is a pretty standard size, I feel, and these are fun. Look how big that is. Holy smokes. So rather than that showing you, look how much bigger that is. I love these. These are great. So you can try to look up how these typically are wired up, but I'll show you guys a pretty easy way how to figure out how these are wired up. Looking online, the first pin, or the pins in the middle, on top and bottom, are connected, and that's where power comes, no, that's where the grounds are connected for all the LEDs. So an easy way to go about it is, so you grab your multimeter and first go to continuity check, and then you can just go from the center pin to center pin and check it. So now we know that center pin is ground. So what you can do is essentially go with diode checking mode and then actually see how everything's connected. And typically the nomenclature they use is this top section's A, then it goes B, C, D, E, F, G, and then display dot. So if we just check around here, oh, that's like F or something. Oh, there's A. There's B. What if we come down? Nope, dot. There's C, D, E, and then F, G, and then the dot was over here. So now we know how it's connected up, and we can do more fun things. So let me show you what I've done so far. This is what I have done so far. I wanted to get it set up so that way I could just write some simple code and make sure that the shift register could work. I know it's metal, but I'll be careful. So we've got an Arduino Nano here that I just had lying around that I could use, and then what we have is these two brown lines are the clock and data for the shift register, and I'll pull those out in a second. But essentially, we have 5 volts coming into the top, and then the bottom sides are connected with resistors through the shift register. And this shift register like outputs 5 volts or 0 volts depending on if you say high or low. So I just wired it up, threw in some code, and I just used the blinking the blinking example and then added in a function, so every time it blinks on the high side, it'll increment the number and change it to go high. So you can see it is actually working there. Got some wires, and then we will just go, let's see, I think that's the clock, and then data. Oh, and ground. We need ground, right? We will do blue for ground. Okay. So hopefully this will just give you a quick overview of how a shift register works. You can look up a datasheet for shift registers, and actually they should describe in detail like how to use them. And I'm gonna sneeze. Okay, so I'm gonna try to give you a quick overview of how the shift registers work. Over here on the trace, the yellow trace, you see it's going high, low, high, low, high, low, high, low, high, low. Essentially, when it goes from low to high, then the shift register is going to take whatever the blue trace value is. So this first trace right here is, so it's a 1, or it's a high, 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 low. And all the others are high. And the way that I have it set up right now is that for the LED to be turned on down here, then it needs to be low. So the high means it's off. So I think this honestly might be the dot, because I only turn on the dot now. Yeah. See, so for that dot one, the first one's high and everything else is low. And time on an oscilloscope is like, this is first, that's last. So, and essentially what a shift register does is it just shifts in all of these. So if you only send one value, then on the first output, that's the value. But if you send in 2 values, then it shifts the first one in to the second, and then now the first one in, or the second one in is now the first output. Like, I don't know if that makes sense. So just think of it as like pushing blocks. And so you have 8 spaces and you have blocks, and you push a block in, it's in the first output. You push another block in, and now that's the first output, and this is the second output. So you just have to shift in all of the blocks, all of the values to what you want. So right here I'm just doing like 8 values and shifting them out, and you can see it in there. So every time it goes from low to high on the clock, then the data will tell it what to do on the output. Hopefully that makes sense. So yeah, so here's the data on the shift register, and this is all great. And then I got these bigger displays and I put them in here, and I started running into an issue. So with these big old fat displays, what happens is each section actually has multiple LEDs in there, and to get the voltage needed to turn on the LEDs, 5 volts does not work, or 3. So I need actually up to like 10 or 12 volts in order to turn on these segments. And the issue is that little shift register is 5 volts only. And so I have a clip of it, of trying to run on that shift register. What happens is we have 12 volts on the top side, and then when it goes from like 0 to 5 volts on this shift register, between 12 volts and 5 volts, that's not enough to turn them off. And so you still get a little bit of a glow. And we'll insert the clip right here. So now we need a different type of shift register, and after some research I did find a different type of shift register. This one, it still runs on like the 5 volts, but the way that the circuitry is inside is that it acts as like a switch on the bottom side. So you could put 40 volts or 30 volts or 12 volts on the top side, and it'll basically just disconnect the ground. So I had to use a different shift register, and all the bits are flipped, but we can show that, but it's not off of 5 volts on USB. It is off of 12 volts. So let me get 12 volts. We have just a 12 volt wall wart that goes into a barrel jack, and then I have the barrel jack up here. I need to make sure none of the resistors I have in there are touching. But what this allows me to do is now put in 12 volts. So hopefully the camera's picking this up. This is actually really pleasing to look at. Like, I love the look of this display. And one thing, because we need such a higher voltage on that to turn on the LEDs, your multimeter in diode mode is not going to be able to turn them on. I think I was maybe able to turn on the dot because the dot only has like 2 versus like 4 LEDs on it. But there we have it. One thing to note is because of how this works and like whether the transistor on the bottom side is on or off, you do have to flip all the bits. So what I have right now is that there's this small shift register. They're off the same clock line, but they have different data lines. So on the small 7-segment display, I'm able to do the bits the one way, and on this guy, I'm able to do the bits the other way. And then I just have them doing the same value, so that way it's easy to see them happening at the same time. I will say, all the parts I've gotten have been like off Amazon to make things easy. So like here's the those shift registers, and they were super cheap. These are like the 5 volt ones that don't work for the 12 volt system. And then these are also off Amazon, and these were a lot more expensive, but they do the job. I will say all of these, I don't know if I'm going to be able to show you guys at all, but I think these are all reject chips because the package, the casing code, like the printing on top of the package, every single one has a defect and you can't fully read the code. So I think all of these were super cheap off Amazon because the casing doesn't display correctly what it is. And these ones are also interesting. I bought them from a company, and it feels like they're saying that they made them, but looking at the package, it has kind of a TI logo, Texas Instrument logo. I don't know. It's an adventure. At least trying to buy electronics off of Amazon. But hey, at least Amazon did have these big old fat displays. So now that we've made a complete mess of my bench, the question is, what is next? So the next part of this is that I got a bunch of these. So I got a bunch of proto boards. Luckily, there are ones that like just barely with bending the pins fit on the backside of the fat displays. And essentially between all of this, what I'm thinking of doing is grabbing 2 displays and then figuring out how to mount them back to back. And then from there, maybe even mounting them on like these skinny ones. So that way it'd be something like that. And then I can just wire them all up. We can convert this bottom rail to 12 volts. We can wire up the Arduino and also have like a barrel jack. And one thing is, this is like Velcro here. I think I'm gonna remove that. Next is actually, now that we've prototyped everything and we think it should work, actually start building these up. So actually start soldering chips on the backside and putting it all together. But I think that's going to be the next video. I just wanted to bring you guys up to speed, show you what I've done, show you the different parts, how they all work. So now we're at the best starting point. You know, we've proven out that these chips will work, that these displays will work. I'm pretty sure this will work on Arduino rather than this. So this is kind of more of the explanation of like Pinewood Derby timers and kind of where we want to go with it. I think the next video we're going to actually start building it up and getting it to like a working system. I love this stuff. Honestly, it is a lot of fun, and it's so satisfying to like bring up a big old fat display like that. So that's it for today. I'm so glad that you guys came. Hopefully the explanations, you know, made sense and can get you kind of started. That'll do it for this video. Next time we're going to get into more of like the satisfying time lapses and building and soldering things up. If you have any questions or remarks, then put it down in the comments. And I hope you guys hit the subscribe button. If you could hit the like button, that would really help out a lot. Especially since I've kind of struggled to find a lot of this information online. So I'm hoping I can give some of that information here. If you hit the thumbs up button, then that could help other people really find it. And hope you guys subscribe for more projects and to see you guys next time. But that'll be it for now. Hope you have a wonderful day, and goodbye.